Hi all, welcome back to my YouTube channel Code IQ. In today's video we are going to see about the topic the von Neumann architecture. It forms the basic in the subject computer organization. So, what is von Neumann architecture? This architecture was proposed by a mathematician John von Neumann in the year 1945. So, according to this, an instruction and the data required to execute that instruction is stored in the same memory space. That means if you are having an instruction called add R1, R2, where add is an operation performed on the operands R1 and R2. R1 and R2 are called as operands. Operands are nothing but values upon which we perform certain operation. So these operands, they are stored in the register R1 and R2. Okay, so what is register? It is a memory unit. We will see later. So R1 and R2 are called operands and add is an operation. So according to von Neumann architecture, these instruction and the data required to perform the instruction is stored in the same memory space. In this example, if you see instruction 01, instruction 02, they are two separate instructions and you have one field called data value that will be having the datas. So, when the instruction and the data value share the same memory space, then it is a von Neumann architecture. And there are four main components in architecture. The first one is CPU, memory, input, output and system bus. So what is CPU? It forms the brain of the computer system. This performs all the operations that we give. Okay, and how does it execute? Is in the concept called stored program concept. That means it fetches the instruction from the memory and decodes it and executes the instruction. So whenever we have certain instruction to be executed, it will be stored in the memory space and it will be fetched, then it will be decoded and executed. And second component is memory. Obviously we will need memory to store the data and instruction. And third one is input and output. These input and output are nothing but the devices from which we get the information and to which we give the output. And at last is system bus. This is nothing but to have connectivity or communication among all these devices, we have a bus called a system bus. Now let us see what is inside the CPU. Inside the CPU, the first unit we have is a control unit. So this control unit, it generates the signal that helps the system to understand what operation has to be performed. And second one is ALU, arithmetic and logic unit. So this arithmetic and logic unit, it performs all the operations like arithmetic operation and logical operation. So what operation has to be performed? That is given by the control unit. And next is register. Registers are nothing but ultra fast storage slot and it is located inside the CPU. So, and most common registers which is used are accumulator. Accumulator is used to store the temporary values and program counter. In the first example here, we have seen instruction 1, instruction 2, correct? So we will not be knowing which instruction to be executed, right? So the CPU will have a register called program counter in which the address of the next instruction to be executed will be stored. So when execution of an instruction gets over, the CPU checks for the address of the next instruction. And on that address, it will fetch the instruction, it will decode it and it will execute it. So that is the purpose of having a program counter. And next is memory address register, it stores the address, and memory data register, it stores the data. Then last is instruction register. Program counter, what does it hold? It holds the address of the next instruction. But instruction register, it holds the current instruction that is being executed. And this is the stored program concept, that is the fetch decode execute cycle. The instruction will be fetched by the CPU by seeing the program counter, and upon which the instruction is received or retrieved by the CPU. And in the second phase decode, it decodes what are all the operation it has to be performed and what is the operands that are required, and it goes to that particular memory location and get the operands also, and at last in the phase it will execute the instruction. But what is the bottleneck of von Neumann is, as both the memory and this as both data and instructions sharing the same memory space, like one bus and one memories, so the CPU cannot fetch an instruction and read write data at exactly the same time. If it tries to perform the same time, then traffic jam is created. There is one more architecture called Harvard architecture. In Harvard architecture, we will have a separate memory space for instruction and data. So both can be accessed simultaneously. As in von Neumann, only one memory space is used, it cannot be accessed simultaneously, but in Harvard it can be accessed. And next is, it is faster when compared to von Neumann, but more complex, and it involves more hardware to be used. So nowadays, von Neumann architecture is the most commonly found in general purpose computers, mostly by Intel and AMD companies. They use it, ARM chips. So all these, all these companies, they use this von Neumann architecture. So at last, we'll just have a recap of what we have seen. The first is this von Neumann architecture. It uses stored program concept, where data and memory will be stored in the same memory space. Data and instruction are stored in same memory space, and it executes the instruction, the concept called stored program concept, that is, it fetches, decode and execute it. And main bottleneck is, as both are sharing the same memory, so the simultaneous access is made as a main bottleneck. And in Harvard architecture, like, we have a separate memory space, so simultaneous access is quite easier. Thank you for watching. We'll see you in another video.